In this video, we'll be writing the equation of a curve. We can see that this looks like a sine curve. Starts at the origin and goes up and then hits the axis and comes down and then hits the axis. So we can write the equation of this curve as a sine function. I'm going to go ahead and put in my basic stuff here. My center line is right in between 8 and 12. So we could add those two together and get 20 and divide that by 2 and get 10 and see that our center line is 10. Or you can take the space in between them, which is 4 units, and half that and get 2. So 2 down from 12 is 10. Or 2 up from 8 is 10. However you feel comfortable doing that. So our center line is at 10. And then our amplitude is how many units from the center line to the max. So we can see that that's 2. So we'll put plus 2 here times the sine. Now I can see that this curve is squished so that there's more than one curve done in the usual 360 degrees. So a fast way to get the coefficient of my argument would be to count the number of curves, but that's not always accurate. So what I'm going to do is determine how many degrees in one period. So starting at 0 and go up and then down and up to the axis again. This is the end of one period. So I can see that one period is 90 degrees. So I'll use my formula, period equals 360 over b. And I counted that my period was 90 degrees. I have 90 equals 360 over b. Now I'm just going to solve for b. Multiply both sides to get it off the denominator. And so I have 90b equals 360. And then divide both sides by 90. And b is equal to 4. So for my equation, my coefficient of my argument is 4, and my variable is theta. Now, when we counted, we can see that we have, there's 1 period, 2, 3, 4. So there was 4 periods.